So in this section, we're going to be revisiting areas. So we've already learned how we can find areas using integrals as long as it's just the area between one function and the x-axis. If the region is above the x-axis, the area and the integral are exactly the same. If the region is below the x-axis, the integral is a negative value when I make it positive to get the area's positive value. We're going to extend that in this section as we talk about finding areas, and that we're going to focus on finding the areas between two functions. So it's no longer between one function and the x-axis, it's between two functions. And we'll even extend that further to what if they're not even functions. So to kind of put a grounding into what we're doing here, if we revisit the ideas of how we started learning about integrals, which is through area, if I wanted to find the area between the x-axis and the function 8, from 1 to 8, I went ahead and graphed it. And we said, okay, well, that gives me a rectangle, and I know how to find the area of a rectangle. Well, it's the height, 8, and its width is going to be 8 minus 1, which gives me 64 minus 8, which is 56. But we also tied that to integrals and said, well, that's the integral because it's above the x-axis. That's the integral from 1 to 8 of my function with respect to x. So I can use antiderivatives to calculate that. That's 8, and that's still 56. The idea of what we're going to be doing in this section, though, is in the second example here, finding the area between the function 8, f that I'm saying is 8, and g, which is 4, on that interval from 1 to 8. So again, I graphed it, my x-axis and my y-axis. I have the function 4 for g, the function 8 for f, and I want that region in between. Well, I can see it's still a rectangle. Its height, though, is the top function of 8 minus the bottom function 4. And then its width is that 8 minus 1, and still. So I've got 4 times 7, which is 28. In terms of integrals, if I were to do the integral from 1 to 8 of just f, that gives me all the way down to the x-axis, which I don't want, so I need to take away or subtract the integral from 1 to 8 of g. But because these have the exact same bounds and they're both with respect to x, I can combine that into one integral using my sum and difference property. So that's the integral from 1 to 8 of 4 dx, which is 4x from 1 to 8, which is 32 minus 4, which is still 28. But the key idea of this is our width, the way we calculate the width of the rectangle didn't change, it's the height. And the height is the top minus the bottom. So we said that this is the top minus the bottom. And that's actually the idea of how we're going to find areas between two functions. We're always going to do top minus bottom for the heights. And then remember that rectangles are what we based integrals off of. Integrals are RAM with an infinite number of rectangles. All that we had to figure out were the heights. Well, the heights are always going to be top minus bottom, top minus bottom, top minus bottom. So even though we have below the x-axis, this still works. So if I think of it in terms of rectangles, my width is still the 8 minus 1, which is 7. But now my height is the top minus the bottom. But because my bottom is a negative number, that becomes what we would be more used to seeing as a 3 plus 2 to get my height of 5. But to get it to be adding a positive, that's why we have it as subtraction. It's still top minus bottom. So if I think of it as an integral, I have the top is 3 minus the bottom of negative 2. That's the integral from 1 to 8 of 5. which is 5x from 1 to 8, or 40 minus 5, which is still 35. So some examples of this that are a bit more typical, not quite as basic. If I want to find the area between the function secant squared and the function sine of x from 0 to pi over 4, I am a big believer that we should look at the graphs. Now, you have to be comfortable that, remember, 2/3 of the questions on the AP exam are no calculator, so I'm going to go through graphing this without the calculator. It doesn't need to be perfect. So I have my x and y axis. I'm going from 0 to pi over 4. Sine is a little bit easier for me. I know that sine of x, oops, sorry about that. I know the sine of x at 0 is at the origin, and at pi over 4 is at rad 2 over 2, which is about 0.7, and curves up like this. So this is my g of x equals sine of x. For the secant squared, well, that's 1 over cosine squared. When x is 0, cosine is 1, so 1 over cosine is 1, and 1 over cosine squared is still 1. So here at 1, I know I've got, oops, the secant squared. But now, secant squared is really a parabola because I'm taking some number squared. So, and it's opening up, and there's secant squared. I can now see, the reason I recommend this is I can now see what is on top, what is on bottom, and I'll be doing the integral for 0 to pi over 4, my top, secant squared, minus the bottom, sine, with respect to x. Antiderivative of secant squared is tangent. Antiderivative of minus sine is plus cosine. And I can take the derivative to check my answers. Derivative of tangent is secant squared. Derivative of positive cosine is negative sine. So that's looking good. From 0 to pi over 4, plug pi over 4 in first. Tangent of pi over 4 is 1. Cosine of pi over 4 is rad 2 over 2. And minus tangent of 0 is 0. And cosine of 0 is 1. And I'm not required to simplify, so there is our answer. That is a fairly typical one you'll see, especially no calculator. We can also be given one such as this. Looks similar, but there's a small difference to this. We're asked to find the area enclosed by y equals 2 minus x squared and y equals negative x. Notice they don't tell us what x's we're going between, so we actually don't know the bounds for this yet. So I'm going to start by sketching a graph. So my x and y axes. 2 minus x squared is a parabola opening down with a vertex at 0, 2. So this is y equals 2 minus x squared. And then y equals negative x is a line with a slope of negative 1 passing through the origin. So that means I can now see that here is the region I want to find the area of. But I don't know what x's should be between. I can see top, I can see bottom. So I can see I'm going to be doing the integral. The top is the green, 2 minus x squared. The bottom is the negative x in red. But I need to figure out what should x be between. So I actually need to find my intersections to see what x is between. Remember, to find intersections, it's where my functions are equivalent. So I set the 2 minus x squared equal to the negative x. And we move everything over to the right-hand side. So I have 0 equals x squared minus x minus 2. I'm going to solve this quadratic by factoring. So x minus 2 times x plus 1, which means that x is equal to 2 and x is equal to negative 1. So I can see that my bounds are going to be the negative 1 to 2. I can now go ahead and do this antiderivative by hand. So I have 2x minus 1/3 x cubed plus 1/2 x squared from -1 to 2. Plug in my upper bound first, then subtracting, plugging in my lower bound. Again, I am not required to simplify, so there is my answer. And again, please watch and be careful of your parentheses. Parentheses are really important as we are doing these.